So our topics today is about validity and reliability of questionnaires. Am I ready to collect data? Okay. So at the end of this sharing session, participants will be able to describe the benefits of using questionnaire as measurement tool, describe level of measurement according to Stevens taxonomy, define validity and reliability, distinguish between different types of validity and reliability, determine specific statistical procedure related to validity and reliability testing, and last but not least, differentiate software that can be used to analyze validity and reliability. Okay, so let us talk about questionnaire. Yeah? Questionnaire is a type of research instrument consisting of a series of questions. Okay, aims to gather information from respondents. So if you are using survey, then you must have using the questionnaire. Particularly in this PKP situation, where you cannot go out and collect data by yourself. So online survey is quite convenient to be conducted. Yeah. So why we use questionnaire? Because it is easier in terms of data collection. Okay. Okay. So why it is easier? Because say for instance you are doing online survey, so you share the links. If you have a strategic or systematic way of sharing, you know how to share to specific group of people, then you are going to have large amount of information and large amount of people, very large sample size. You can easily get hundreds, or maybe you can achieve thousands from online survey. And then you can do questionnaire research in short period of time. You can finish data collection within a shorter periods of time compared to other types of research design. Okay, particularly performance testing, because it is just about participant will only take about like 15 to 20 minutes to complete the research questionnaires. Yeah, and it is also cost effective. Google Form is free. Even paper pencil is the cost is only printing the questionnaires. Yeah, so it is cost effective. Because questionnaire is mostly self-rated. Okay, because questionnaire is mostly case-rated, so it has like minimal threats to its validity and reliability. We still have threats to validity and reliability, but it is very minimal because the participant will answer the questionnaire based on their perception or understandings about what the questionnaire is all about. Because of that, the questionnaire must be validated first. We need to test for validity and reliability, undergo feasibility testing. Okay, so it is easily quantified using software package. If you are using online questionnaire, for instance, you can get the data from the Google form, and then you can just download the data using Excel, and then you can always convert from Excel to SPSS. Yeah. When you have your data ready in Excel or SPSS, then your analysis can be analyzed objectively. It looks very systematic and scientific if you are using data from questionnaires, even though it is just questionnaire, because the variables is large. You can always analyze using easy statistical tests and up to very advanced statistical tests. Yeah. Okay. So let's move on. Okay. In a questionnaires, you will have two types of variable. Okay. The first one is observed variable, and the second one is latent variable. Okay. Latent is a Latin word for hidden. Yeah. So let's have a look on observed variable first. Observed variable is the variable that can be measured directly by the researcher. Okay, so you have, say for instance, age. Age can be easily determined. Okay, years old, for instance. Weight, you will have your weighing scale. Height, range of motion. You can always use a goniometer to determine the degree of rotation, as well as gender. Yeah, male, female. Yeah. So that one is observed variable, the one that can you see directly. The second one is latent variable. Latent variable is also known as factor or construct. Sometimes it is called latent construct. Yeah, so it is hidden, whereby the latent variables cannot be observed directly by the researcher. Say for instance, quality of life. There is no ruler that can measure quality of life. So that direct observation is impossible for quality of life because it is latent, latent variable. And then depression, perception, belief, and many more. Although it cannot be measured directly, it can be reflected. Yeah, it can be reflected by using relevant indicators. So if you have, like, say, quality of life as a construct, then you may have like 10 questions that reflect quality of life. So that 10 question is actually observed variable for these latent variables. Yeah. Okay. So this is, for instance, latent construct. So you have depression as your latent construct. So in this figure, as you can see, there are 4 indicators that can reflect depression, which is fatigue, insomnia, loss of interest, and also suicidal thoughts. Sorry. Okay, so even fatigue, somehow fatigue can also be considered as latent variable. So if you have questions that can reflect fatigue, or you have questions that can reflect insomnia, so our graph will be bigger. So you depression to fatigue, and then fatigue to questions. Okay. So in that case, we can call our graph as second order construct. So this one is first order construct. First order construct. So if you have another construct below the subconstruct, then you can call that model as second order construct. Yeah. Okay. Okay. So in research, particularly in proposal, yeah, if you like to start your study, you must have sort of a theory that can you rely on. You must start with a theory, or your research is to develop theory. But from experience, I mean, it is easier to obtain an already established theory, but use that particular theory in your certain issues. Say, for instance, this one. Okay, this is a theory called theory of planned behavior. Theory of planned behavior. Those who are in psychology or social science is more familiar with this model. Okay, so according to the TPB, theory of planned behavior, behavior can be predicted by intention, and intention can be predicted by attitude, subjective norm, and perceived behavioral control. So this is the theory. So this is the theory. Okay. So you can adapt this theory because behavior is depending on the researcher. Say for instance, I'm looking into the behavior of exercise or physical activity or the practice of martial arts, for instance. Yeah. So you can always adapt this theory. Once you adapt the theory to switch your study, then it becomes conceptual framework. So this is theoretical framework. From theoretical framework, you can have your conceptual framework. So in this framework, the researcher is going to predict the behavior of birth of a child, predicting intention to have a child. So this is their construct and then sub-construct. Okay. So in order to measure this latent construct, they need to have indicators, questions. Yeah. So okay, this is the model. This is the model. Some researcher might use the term hypothesis model. So hypothesis model is equal to conceptual framework. So this is a model, our model that we want to test. We have our model, and then we collect data, and then we analyze to see whether our model can fit the data. So the ultimate aim of research is to fit the model to data. If it is fitting well, so your result is good lah. Okay, so wait, I need to admit. Okay, for each indicators, in order to capture the information, you must have rating scale. Okay, each latent construct must be reflected by indicators. For each indicators, a response scale is needed to acquire information. So there are three common types of rating scale. There are three common types of rating scale. The first one is dichotomous scale or binary scale. Yes, no, for instance. True, false. Yeah, high, low. So there are only two categories in the scale. So dichotomous scale. Another one is rating scale. Okay, rating scale. So the rating scale can be 1 to 10 rating scale, 1 to 7 rating scale, or 1 to 5 rating scale. Yeah. And last but not least, semantic differential scales. For the semantic differential scales, you will have one statement, and then you will have several responses. Say for instance, in this example, for me, exercising at least 6 times in the next 2 weeks would be, okay, 1, very bad. 7, very good. Another response would be not important, and then very important, and so on. So this one is semantic differential scales. Okay. Okay. So okay, we need to consider what is the level of measurement for our we need to consider level of measurement for the indicators. Yeah. So therefore, you need to understand what is the meaning of level of measurement according to Stevens taxonomy. So according to Stevens taxonomy, we have 4 levels actually: nominal, ordinal, interval, and ratio. Okay, so nominal is the category with no ordering or direction. Say for instance, male, female. Yeah. Ethnicity, Malay, Chinese, Indian. So this one is nominal. Second one is ordinal. Ordinal is the ordered category. Okay. However, it has unequal interval between the categories. For instance, low, high, disagree, neutral, agree. Okay. This one is three level of ordinal scales. Okay. So unequal interval between categories means the distance between 1 and 2, or the distance between disagree and neutral, is not equal to 2 and 3. Okay, so that's why it cannot be measured as interval. Okay, so I combine both interval and ratio because in statistics, this difference is not that much of an important, because we consider both interval and ratio scale as continuous variable. So for interval and ratio scale, it has equal interval with or without absolute zero. This one is less important lah. Okay. So interval and ratio can be considered as continuous variable, where ordinal and nominal variables can be considered as categorical variable. So for categorical variable, the only test that we can use to analyze the data is non-parametric test. But for continuous variable, we can go up to parametric test. And there are so many options in parametric test that has no equivalent in non-parametric test. For instance, if you would like to do a split plot ANOVA in using parametric test, there is no equivalent non-parametric split plot ANOVA in non-parametric test. So you have no options rather than using 2 times of Wilcoxon and 2 times of Kruskal-Wallis or Mann-Whitney. So you still need to use non-parametric test. So the limitation of that is that you cannot see the interaction effect. So that one is an issue of specific types of analysis lah. Okay. Wait, yeah. Okay. Okay. So let's move on. This is still in the context of rating scale. Rating scale. So if you have your rating scale, you need to decide whether your rating scale is ordinal or interval. Ordinal or interval. Okay, so if you are using ordinal Likert scale or ordinal rating scale, your indicators, the response scale would be 1 mostly disagree, for instance. You have name for each categories. 2 disagree, 3 neutral, 4 agree, and 5 mostly agree. Okay, because it is ordinal, each categories has names pointed to them. Okay, but if you are using interval scale or interval rating scale, you only have mostly agree, and then 1, 2, 3, 4, 5, and at the other end you have mostly agree. So the participant can indicate their agreement between 1 and 5 according to their perceptions. Okay, this one as well. Mostly disagree, 1, 2, 3, 4, 5, 6, 7, and then mostly agree. So this one is 1 to 7 like rating scale, and the last one is 1 to 10 rating scale. Yeah. So for interval rating scale, you can treat each item as interval continuous, which means that you can use parametric test, okay, for this questions, because according to Likert, 1932, this one is very old paper lah. Okay, so for individual item, 1 to 5 scale can be potentially treated as interval, at least 5 scale lah. at least 5 scale, can be treated as interval. For the total score, it can also be treated as interval. So if let's say that you have 1, 2, 3, 4, 5, and then you have 6 questions or 7 questions, you calculated the total score, and then that total score can be treated as interval. But sometimes statisticians will disagree, because they say if you are going to start your study with already ordinal rating scale, how can you use a total score and you treat that total score from the ordinal rating scale using parametric test? Because from the start, it's not interval. So that's why the current pattern is we are using interval rating scale rather than ordinal rating scale. So for postgraduate student, please take note lah. Okay. So the importance of this matter is that, say for instance, you would like to test for construct validity. Yeah, construct validity. One of the assumptions for construct validity is that each item must have a approximate normal distribution. Okay. So if your scale is ordinal, so how can you test for normality? So you can't. Normality is only meant for interval rating scale. So that's another argument lah. Okay. So once you have already have your indicators, say for instance, you like to do to check for spirituality. So spirituality is your latent construct. So you have 16 questions that reflect spirituality. So you can assess whether this 16 construct is accurately representing spirituality. So one of the tests is so this is confirmatory factor analysis lah. Each of these arrow has value. So this value is actually factor loading, or in CFA we call this as unidimensionality. Wait, yeah. Okay. Yeah, this is a CFA. If let's say that your factor loading is less than 0.5, then we need to exclude the item. We need to remove the items. Okay. So before you calculate the total score, you need to establish that each question have a good factor loading, loaded well into spirituality. Okay. So this is how lah. This one is taken from my undergraduate student lah. Okay. If you can see here, this one is E1, E2, E3, E4, E5. This one is measurement errors. Measurement errors. So in some software, we can calculate the measurement error. In SPSS, we assume measurement error as 0. Okay, but in specific software, for instance, IBM SPSS Amos, we can take into consideration all these errors, so that we can really confirm that our items is or converge into spirituality. Okay. 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 So on the left bottom side, you can see these numbers. These are what we call fit index. Fit index. Remember, the ultimate goal of research is to fit the model into the data. So how to check the fitness? So this is the value lah. This is the fit index, one of the measures for construct validity. We're going to look into this in detail later on. Yeah. Okay. Okay. So then, from there, if you have already established your CFA, so now you have self-esteem. So self-esteem has CFA. So self-esteem has its own CFA. Social support has its own CFA. Well-being has its own CFA. So you have 3 CFA. Once you have confirmed all your latent construct has good validity and reliability, then you can run statistical test. Sekejap nak kena admit dulu. Okay. So this is what we call structural equation modeling. It is a second generation of multivariate analysis. So before this, we do MANOVA, two-way, independent ANOVA, MENCOVA, SPANOVA. Yeah. So that one is first generation. This one is second generation of multivariate analysis. Okay. Okay. So before this, if you want to look the how social supports influence well-being, you can always do a linear regression. But by using the traditional methods, which is the linear regression, you are just using the total score. You are using total score. Whether or not the total score has good validity, you don't know. Okay, so from here, from structural equation modeling, you need to establish the validity and reliability first, and then after that, once everything is valid and reliable, then you can proceed with the analysis. So the analysis of this picture would be a mediation analysis. Yeah, we would like to see how self-esteem mediates the relationship between social supports and well-being. And this is the regression coefficient, standardized regression coefficient, 0.242, 0.468, and 0.324. Okay, so this is how structural equation modeling can be conducted. Okay, let's move on. Okay, so a little bit on the definition of validity and reliability. Okay, wait, yeah. Okay, so validity is about how accurately a method or tool measures what it is intended to measure. It is about accuracy. What about reliability? Reliability is about consistency. How consistently a method or tools measures something. Okay. So in the first picture or figure, you can see that this one is reliable because it is consistent. However, it is not valid because it is not hitting the inner circles of this focus board or target board. Yeah. So a measure or a measurement tools can have a high reliability but low validity. Okay. The second picture, in order for an instrument to be valid, it must have reliability. So in general, validity is more important than reliability. If an instrument does not accurately measure what it is supposed to measure, there is no reason to use it, even if it is measured consistently. The most useful instrument is both valid and reliable. Yeah. Yeah. Okay. Okay. So let's move on. There are many types of validity and reliability. So the lowest one for validity, the lowest quality would be face validity and also content validity. Although these types of validity is the lowest, has the lowest quality of validity, but it is very fundamental. Okay, so we're going to discuss about these two as well. And then we have concurrent validity, predictive validity, and post-predictive validity. And these three is also called criterion-related validity. which is the ability of an instrument to produce results that concur with or predict a known criterion instrument. So you are going to compare your newly established questionnaire or measurement tool with one or with another criterion, whether that criterion is in the future or in the history or during at the same time concurrently. Okay. So this is criterion related validity, and the highest form of validity would be construct validity. Yeah. So the capacity of an instrument to measure the intended underlying construct. These are considered strongest types of validity. It is not difficult, but you need to have a proper planning. Even undergraduate student can do construct validity. Yeah? Okay. So three types of construct validity: known group validity, convergent validity, and also discriminant validity. Yeah. Okay. So finish with validity. This one is reliability. So there are three types of common reliability testing: internal consistency, test retest, and also rater reliability. Okay. Let's have a look on validity first. Okay. So for validity, the first one we are going to talk about phase validity. So in principle, phase validity is not considered as validity. Although some consider phase validity as the weakest form of validity. But in principle, it is not considered as validity. That's why in papers, you will always see researcher or authors reporting on content validity. So at least content validity has a formal way to be determined. Yeah? But for phase validity, there's no formal way. It is just subjective. It answers whether an instrument apparently has validity for subjects, patients, or participants. So for phase validity, it is common to be given the questionnaire to either subjects, patients, or participants. But some papers already publish that phase validity can also be conducted by content expert lah. So it depends on your study lah. If your content expert is willing to check for phase validity, then that's fine. Okay. So do participants agree that the items and wording are relevant to research objective? So we ask the participants whether they agree with all the items and the wording. Okay, and then it is also related to the appearance of an instrument. Yeah? Is it better to put all the question in a table, for instance? That kind of questions lah. The font size, font style. It is made basically about respondent acceptability. Yeah. Commonly conducted on layman expert. Layman expert is the representative of subject, patient, or participant lah, but can also be conducted on content expert. So this one is phase validity. Okay, the weakest one lah. And then we have content validity. Okay, so content validity is about the adequacy of an instrument in order to capture the domain or universe of the construct it aims to measure. Yeah? So it can be done by reviewing relevant literature and then reviewing existing instrument, and after that seeking opinion of expert panel. So expert panel is a group of individuals who have in-depth knowledge or expertise concerning the domain of interest. So for postgraduate students, when you would like to go and search for expert panel, please make sure that you have like a formal letter lah, so indicating that they are being invited to participate in this phase of research. Yeah? So you need to as well define who is your expert panel. Yeah? It can be those with PhD in that specific field, or those with clinical or industrial experience on that particular field. Okay, and so on. So you, as a researcher, need to determine who is your expert panels. Okay, so there are many ways to quantify content validity. The first one is using content validity ratio. Okay, so content validity ratio is about giving all the questions or item of your questionnaire specific rating, such as essential, useful but not essential, and not necessary. Okay, so your participant or your content expert are required to rate each questions and give their rating lah, whether it is essential, useful but not essential, or not necessary. Okay, so use the following formula using the total number of experts N and the number of who rated the object as essential E. So this is the formula for CVR lah. Okay, okay. So CVR focus on essential only lah, essential. Yeah. The CVR is an item statistic that is useful in the rejection or retention of specific items. After items have been identified for inclusion in the final form, the content validity index is computed for the whole test. So if you have time, you can start your content validity testing with CVR first, if you have time. I mean, some researcher can go straight away to CVI, but in some study they started with content validity ratio first, because this one is just like to screen out not relevant or not essential questions. Yeah, this is just to screen out. Okay, so this is the table that you need to refer after calculating the CVR. Say, let's say you have 15 number of content experts. So the minimum value would be 0.49. If you calculated your CVR and the value is below the 0.49, so you need to reject the items. Okay, so as simple as that lah. CVR, content validity ratio. Okay, the next one and the most popular one is CVI, content validity index. This is the degree to which an instrument has an appropriate items for construct being measured. Okay, for construct being measured, we would like to see whether the items is appropriate. Okay, so we have two types of CVI: item CVI and scale CVI. Okay. Scale CVI is the average of item CVI. Or so-called, we call this type of CVI as SCVI average, SCVI/AV. Okay. Another one is SCVI universal agreement, UA. It is the proportion of item on scale that achieve a relevance rating of 3 or 4 by all experts. Okay. So I mean, these are two different methods lah. Two different methods. I mean, from my experience, SCVI/average is better lah. But you can always report both value. Why it is better? Because okay, this one. Okay, we will go into detail after this lah. Okay, let's talk about the criteria of measuring content validity first. So, if let's say that your first questions is about belief on certain norms, yeah, and you would like to see whether the questions, according to the content validity index, you need to see whether the question is relevant, clear, so you check the clarity, simplicity, and ambiguity. So for each criteria, these are the scorings. So you have 1 to 4 scores lah. 1 not relevant, 2 item need some revision, 3 relevant but need minor revision, and 4 very relevant. Yeah. So during the analysis, you need to combine 1 and 2 into disagree, 3 to 4 into agree, which means that not relevant and item need some revision may be considered as candidates for exclusion lah. Okay. Okay. So we have for content validity index, we are focusing on 3 and 4 lah. 3 and 4. Okay. This one is from Yagmai 2003. He suggested 4 criteria. But from Zaman Zadeh, 2015, this person suggested relevancy and clarity. Okay. From experience, I think it is better for you as a researcher to determine which one is relevant to your study. So if you think that relevancy is enough, so just do relevancy. If you want to include clarity, then you can do both. Okay, so it depends on your needs lah. Okay, so this is how to calculate the CVI, Content Validity Index. So let's say that you have 10 items and you have 6 experts. So to calculate the item Content Validity Index or item CVI or ICVI, you need to calculate the percentage of agreement. That's it. Percentage of agreement is just so let's say that 5 experts is agree. Sorry, 5 expert rated 3 or 4, which means that they are agree that the item is valid or essential or clear or simple or no ambiguity. Okay, there's only 1 expert who rated 1 to 2, which means that this particular expert does not agree with that particular item. So how to calculate the item CVI? 5/6. That's it lah. 5/6. So you have 0.83. 5/6. This one is 5/6 as well. 0.83 until this one. So item 7, 8, 9, 10 has a perfect agreement lah of CVI, which is complete 1 lah, 1.00. Okay. So how to calculate the SCVI average or mean ICVI? So you take the mean or average of all items CVI. You can get or you will get your SCVI average lah. Okay. What about UA, SCVI Universal Agreement? If you look at the table, there's only 4 items receive full marks from all experts. So it is 4/10, 40%. It is 4/10, so 0.4. You will get 0.4 lah. Okay, so for CVI, I mean in general, we would like to see our item to have more than 0.8 lah. But there are many suggestions of for the cut-off lah. So you need to refer to specific paper. If let's say that there is a paper saying that if you have like 5 experts, then your CVI must be more than 0.76, for instance. So you need to cite that paper lah. So it depends on your citation as well. Okay. So this is CVI, very easy to calculate. Okay. Sometimes we have experience, our paper was rejected because we are doing CVI, and CVI is very easy. Okay, just because of that lah. So we need to include other types of validity testing as well. Okay. Okay. Other than CVI, we can also calculate the content validity based on kappa statistic. I've not included here, but maybe I can talk a little bit on kappa later on lah. So you can calculate modified kappa statistic to determine your content validity as well. Okay. Let's move on to criterion related validity. So the criterion related validity is about how well the score of a measurement correlates with the score on another measurement of interest. There are three types of criterion related validity. The first one is post-dictive validity or retrospective. The criterion was in the record, because it was taken earlier. And then you're going to see whether that criterion predicts your assessments now. Okay. So you need to have a good record lah. Okay. Second one is concurrent. Test taken now replaces another assessment now. Usually, when you have you develop your questionnaires, you need to for concurrent validity lah. You need to compare your questionnaire with a gold standard. So if you are comparing with a gold standard, at the same time, you are using or you are measuring concurrent validity. Yeah. Then last but not least, predictive validity. So you take the measurement from your newly developed questionnaire or instrument or measurement tools, and then you wait, say for instance, 3 months, and then you measure the criteria. For instance, functional level is related to quality of life. I would like to design a questionnaire on functional level. So I did my study in January, but I cannot assess quality of life at the same time. I need to wait. Let's say for instance 3 months, and then I will take the measurement of quality of life on that same particular participants, and then I will see the correlation lah. So among these three, concurrent validity is most popular because post-dictive you need to have a good what we call it record. Predictive, it is just like cohort study. You need to follow the participants and measure them again using criterion questionnaire. So it depends lah. If you have time, so you can always do post-dictive and predictive lah. But mostly we use concurrent lah, and that's fine. This is just some of the options that you can take lah. Okay. Okay. So this is just to show you some of the papers or articles that has been published lah. Okay. So for instance, these papers published about post-dictive validity. Post-dictive validity. So, do official hospitalization predict medical vulnerability among the homeless? A post-dictive validity study of vulnerability index. Okay. So, it is highlighted that official hospitalization records significant predicted overall VI score. VI is vulnerability index, but they do not predict the subcomponents of the measure. So this is how you do post-dictive validity. What about concurrent validity? Okay, so this study is about measuring concurrent validity of the International Family Quality of Life Survey, an OT paper lah. Okay. It shows that moderate correlation between the total FQOL score of the FQOL S 2006 and the Beach Center's FQOL scale. So this is concurrent validity. So one of these assessment must be gold standard lah, okay, or most widely used questionnaires. Yeah, and this one is predictive validity. Okay, the baseline pain, what is this? RTWSE, written toward self-efficacy scale. Scores were found to be useful to predict return toward status 6 months post-injury. This is from my field, return toward. So RTWSE can predict return to work, whether the patient can go return to work after injury or not. Okay. Okay. So predictive validity. Yeah. Okay. So finish with what call it criterion related validity. Okay. Now let's have a look on known group validity. Known group validity is demonstrated when a test or questionnaire can discriminate between two groups known to differ on the variable of interest. Okay. Okay. So when there is no gold standard to compare with, known group validity is one of the alternatives for validity testing. Okay. In this approach, the in this approach, the test or questionnaire is administered to two groups that are known to have or that logically should have different levels of the construct to confirm whether the hypothesized difference is reflected in the scores of the groups. Say, for instance, you constructed a measurement on let's have a look on the paper lah. Okay, this one. Okay, validity of LOTCA, Lowenstein's occupational therapy cognitive assessment in people with intellectual disability. So you would like to measure non-group validity using participant with intellectual disability versus participant without intellectual disability. So how to do statistical tests? As simple as independent t-test would do. Yeah? If you would like to go further, you can do multi-group analysis of structural equation modeling. Okay. Okay. So very easy. Yeah? Just do independent t-test for normally distributed data or Mann-Whitney for not normally distributed data lah. Okay. So you can calculate the p-value as well as the effect size. If let's say that you are using independent t-test, so you should report your p-value and report the effect size as well. Cohen-D. So Cohen-D is the effect size for the t-test family. 0.2 to 0.5 small difference. Okay, 0.5 to 0.8 moderate difference. Yeah, more than 0.8 large difference. So that's how lah. Okay. 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 Now we move to other types of construct validity lah. So the first one is known group validity. Okay. The second one is based on factor analytic methods. Let me show you. Okay. Wait, yeah. Okay. So for convergent and discriminant validity, usually we will use factor analysis. Okay. So there are two types of factor analysis. The first one is exploratory factor analysis, and the second one is this confirmatory factor analysis. Yeah. So just want to share about the difference between EFA and CFA lah. So EFA is the exploratory factor analysis. CFA is confirmatory factor analysis. So in EFA, the dimension and indicators for teacher competency are unknown because we will just have our questions ready, let's say 20 questions, but we don't know the sub construct or domain that can group all the specific items. Say for instance, in this CFA CFA, we already know the domains for each item. Say for instance, behavior 6, 7, 8, 9, 10 is under teaching strategy. Class management 1, 2, 3, 4, 5. Interaction with people 11, 12, 13, 14, 15. So if we already know the domains and its specific indicators, so we can always use CFA. But if we don't know, then it is good to start with exploratory first. Okay. So exploratory factor analysis can be done using SPSS. Very easy lah. Okay. So we have principal component analysis, we have principal axis factoring in SPSS. So we can, I mean, the most popular would be the principal component analysis lah, PCA. So we can always do PCA to determine the underlying domains or the underlying construct, because we don't know. But if we already know, then we can straight away do CFA. Okay. It is common to found in a PhD or in postgraduate study, they will start with EFA first. And then after doing EFA is just like pilot study, pilot study. But this pilot study requires participant at least 100, not 30, 100. So during your pilot study, how many sample size do you need is based on what type of statistical test are you're going to use. So if you are going to use EFA, then 30 is not enough. You're going to use sample size 100 or larger lah. Otherwise, you cannot obtain the valid results. Yeah. For CFA, it is even bigger, more than 200. More than 200 usually lah. There are specific sample size calculation lah, but I don't want to touch into that because it is too detailed lah. But at least 200 lah for CFA. EFA can be used, can be analyzed using SPSS, but CFA cannot. We need to use other types of software. For instance, there are two types of structural equation modeling. The first one is covariance-based structural equation modeling. So these types of structural equation modeling use a specific algorithm, which is covariance based or maximum likelihood, they call it. Another one is partial least square structural equation modeling. Partial least square structural equation modeling. Okay, PLSM they call it. Okay, so for covariance based structural equation modeling, CBSEM, you can always use IBM SPSS AMOS. IBM, SPSS, AMOS, or simply AMOS. Okay. So SPSS for EFA, we use IBM SPSS Statistics, or previous name would be just SPSS lah. But now the latest name would be IBM SPSS Statistik. For CFA, AMOS, the name would be IBM SPSS AMOS. Okay, that one is based on covariance-based structural equation modeling algorithm. Yeah. So we can use, we can calculate CFA from AMOS. We can also calculate CFA from PLS-SEM algorithm. Okay. So for PLS-SEM algorithm, we can use a number of software. For instance, Smart PLS. Yeah. Smart PLS. And then we can also use Adanko. So for Smart PLS, you need to pay every month, I think. It is you need to pay for the license. It is on rental basis lah. Okay. Even Adanko, you need to pay, but yearly. So that's why I always prefer my student to use Adanko, because it has longer valid time lah. Okay. So that's that lah. Okay. Construct validity, EFA versus CFA. Okay. When you are developing new scales, researchers should conduct EFA first followed by CFA. This one is normal practice lah. If you are developing a questionnaire, a new scales, but you don't know the domains, you can do EFAs first to determine or confirm the domain, and then you can, to determine the domain, and then to confirm the domain using CFA. And the respondents for EFA cannot be the same in CFA. So you need to use other groups of samples. Yeah, you cannot use the same samples or same subject. So if you have 100, then you need to do to search for other 200, for instance, to do CFA. Okay, that one is in ideal world. In an ideal world. Be careful lah. Be careful, because maybe some of you would like to do internal pilot. Internal pilots means that you do pilot and then the pilot will be included in your study. So that one you must be very detailed in terms of your explanation and writing in your thesis. Okay. But if you ask those in social science or in accounting, so they say EFA and CFA cannot be using the same participant. That's it. Okay. But the argument is whether you are using internal pilot or external pilot. That one is has no published articles yet talking about that. Okay. So EFA is data driven. EFA is data driven because you let the software to explore the domains. Yeah. Whereas CFA is based on theory, or empirical research. Okay. An exploratory factor analysis followed by confirmatory factor analysis were conducted for data analysis. Okay. Okay. EFA should be followed by CFA using a different sample. Okay. Okay. To evaluate EFA, inform a priori theory about the major factor structure and psychometric properties. Okay. Already explained. Okay. Okay. Assessing construct validity using EFA. Okay. So sample size at least 100. So we should look for KMO, Kazamaya-Oking, measure of sampling adequacy. Okay. And then we should look for Bartlett test of sphericity. We can look for communalities, and we can determine the factor loading. Okay. I can show you how to do exploratory factor analysis, but I hope the time is enough lah. So let me show you a little bit on FA lah. Okay. So I already have my data here, which is this one. Okay, EFA. Okay. Wait, yeah. Okay. Okay, nice. Okay, so we have B1 to B5 measure, and then C1 to C5, D1 to D5. Okay. So this one is constructed, but it is not determined. The construct is not determined yet. Okay. But during the construction of items, you must at least have some sort of idea on what construct is going to be obtained from the EFA. So that's why you need to learn validity and reliability before you collect your data. You need to know what is validity, what is reliability, in order to plan for a good research. Yeah. Okay, so analyze, dimension reduction, factor. Okay, so because I would like to do to look at the specific domains of my question, so I will have to put in all my questions into the cells, and then I need to to know the KMO and Bartlett test as well as NT-image. And then I can do extraction. My extraction is based on PC, principal component analysis. There are lots of methods for extraction, which include principal axis factoring. So for the most common one in health science would be principal component. And then I can click for the scree plot and then continue. Rotation, usually we can use Varimax because we assume that most of our domain has no correlation to each other. Yeah. So this one, continue, options, suppress small coefficient below 0.5. This is factor loading. So I would like to suppress items that below 0.5 because I don't want to include them. Okay. Continue, and then I click OK. Okay. So the KMO is good, more than 0.5, more than 0.6. So I have a good adequate sample. My sample is adequate. If let's say that your sample size is below 100, so you can always try to defend your result using KMO lah. If the KMO is good enough, more than 0.5, more than 0.6, then you can say that you have adequate samples. Okay, and for the Bartlett test, we want it to be significant. Some of researchers say must be less than 0.05. Some other researchers say must be less than 0.001. So it depends lah. So according to Allen and Bennett, for instance, the most common book used by our postgrad, it says less than 5% is good enough lah. Okay. Okay. So this is NT-image correlation. The diagonal values 0.849, 0.916. We need to make sure that all these numbers are more than 0.5. If let's say that there is an item less than 0.5, we need to exclude that item. Yeah. Move on to communalities. Okay, for communalities, we want our extraction to be more than 0.4. If it is less than 0.4, you can remove your item as well here. Okay, so from this total variance, the statistic tells me there are 4 components from the extracted from the analysis. Okay. So this is rotated component matrix. So you have 1, 2, 3, 4. Yeah? 1, 2, 3, 4 components. So component 1 consists of these questions. Component 2 consists of this question. Component 3 consists of this question, and so on. And after that, you need to give names to each component. Okay. So this is how you use so-called what we call it EFA. This is how you use EFA. Okay, I think our postgraduate students, you have already attended the class on EFA lah. So this is just a refreshment lah, a refresher. Sorry, refreshment. Oh, sorry. Okay. 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 So let's move on. Okay, so this is EFA. Another one is CFA. This is the most powerful way to determine validity, which is the construct validity. So the sample size is, you need to have more than 200 lah, more than 200 to justify your sample size lah. Okay, so what to look for in construct validity? You can assess the unidimensionality. Unidimensionality means how each item loads to the specific constructs. The factor loading. It is the regression standardized beta coefficient actually. Unidimensionality. Okay. The second one is convergent validity. The degree to which individual indicators reflect a converging in comparison to indicators measuring other constructs. So the convergent validity can be calculated using average variance extracted, AVE. Okay, so the AVE must be more than 0.5. You can also look at the discriminant validity, the degree to which indicators differentiate across construct or measure distinct concept by examining the correlation between the measure of potential overlapping. Okay, so this one is discriminant validity. So last but not least, construct validity. So all of these are already actually can be considered as construct validity. But in MOS, in that particular software, they have specific tests just for determining construct validity. They have which is called fit index. Okay, fit index. So construct validity in MOS can be determined specifically using fit index. Okay, so this one is valid for CB-SEM, covariance-based structural equation modeling software lah. Okay, if you are using PLS SAM, say for instance, Adanko, so both are using partially square structural equation modeling algorithm. So the fit index is not available. Although fit index is available in that software, but it cannot be trusted. It is not reliable. Okay. So this is the fit index. So we have three types of fit index: absolute index, relative index, and also parsimonious index. Say for instance, for absolute index, we look at GFI for instance. So your GFI value would must be more than 0.9. Okay. So if you have more than 0.9, you have construct validity, or you have good fit index based on absolute index. Yeah. Okay. So relative and also pengubahsuaian, parsimonious. So at least one index is good. At least one index is larger than the specific cutoff is good enough lah. So let's say that the GFI is less than 0.9, but the root mean square RMSR is less than 0.05. So you can always use only RMSR, not GFI, because GFI is not good because it is less than 0.9. Yeah? Okay, so at least one lah, at least one test in the index in this absolute, relative, and parsimonious. Okay. Okay, this one is MOS lah. MOS is MOS stands for analysis of moment structure. Analysis of moment structure. Structural equation modeling. Yeah. This one is smart PLS. Very popular now. Yeah. And then this one is Adanko. Adanko. Okay. So still have time. Okay. So just would like to share how to check for CFA lah. So I need to open my Adanko first. Where is the Adanko? Okay, Adanko. And then I will open an existing project, which is data for an Adanko. Okay, and then I remove this one first, first contract, and then I will import the data from my computer. This one, I think. Open, finish, finish. Okay, so I need to select indicators has been determined from the EFA. So EFA will inform your CFA. Say for instance, B1 to B5 is already analyzed and confirmed from the EFA, and I put it here. C1 and C4 here, and then D1 and D4 here. Okay. Okay, and I enlarge the picture, and then okay, let's have a look on the first the first parameter, which is the unidimensionality. Yeah. Okay. So for B1, the unidimensionality or the factor loading is more than 0.5. So we want our indicators to have factor loading more than 0.5. So for this construct, we can always name this construct as construct maybe depression, depression. Okay. Okay. So depression is good enough. What about this one? This one is maybe anxiety. Anxiety. Okay, so anxiety is also good enough, more than 0.5. And what about this one? Stress. Stress. Stress is also good enough. Okay, more than 0.5. Okay, if everything is good to go, then we can run the analysis. Show results. Okay, I'm showing the results. Wait, yeah. Sometimes I need to refresh. Okay, so this is the result or reports from the Adanko. Okay, so this is the picture. We can always copy paste this picture in our thesis, into our thesis. Yeah. Okay, so this one is fitness index for Adanko. As I said before, fitness index in both Adanko and PLS, smart PLS is not reliable. So we can just disregard all this goodness model fit me. And then we can look at the construct reliability. So from construct reliability, you can determine internal consistency. See, you have Cronbach alpha here. Cronbach alpha is not enough nowadays lah. So we need to accompany Cronbach alpha with other measures as well, such as Joris-Koch rho and as well as Dijkstra-Henselers rho. So all values are green in color. So everything is fine. So what about convergent validity? So the AVE is more than 0.5 as well, good enough. And then what about the discriminant validity? So for discriminant validity in Adanko as well as in Smart PLS, we use HTMT, heterotroic monotroic ratio of correlations. Any value bigger than 0.85, any value less than 0.85 is considered to have good discriminant validity. Okay, so this one is 0.6851, 0.5 and 0.5, everything is good to go. So you have good discriminant validity for your questionnaires. Okay, so good discriminant validity, good convergent validity, good construct reliability, that's it lah. But at least you check lah, at least you check. Yeah, there are many numbers lah. This one is mostly structural question modeling lah, so you don't need to know for now lah. Okay, so okay, let's move on. Okay, Adanko. Okay, now we go for the reliability. We have half an hour still, that's fine. Okay, so reliability, yeah. So I'm going to discuss about 3 types of reliability. The first one is internal consistency. Okay, the second one is test-retest reliability, and the third one is rater reliability. Yeah. Okay. So the internal consistency. My mentor, Prof. Bahar, always tell me about the internal consistency is about inter-item correlation. So the correlation between each questionnaires, each questions in the questionnaires. Yeah? So if it is high, then it has good internal consistency. Okay. So it measures the correlation between different items on the same construct, inter-item correlation, or sometimes the internal consistency is called item analysis in old books lah. Usually measured with Cronbach alpha. Usually lah. But we have a new school of thoughts lah about this one. Okay, so the rule of thumb for Cronbach alpha is more than 0.7 is acceptable lah. More than 0.7. Okay. So this is how to do Cronbach alpha. Analyze scale reliability analysis lah. So you will have this table, Q1 to Q9. You will need to click the Chrombar alpha if item deleted. If let's say that your Chrombar alpha if item deleted is sort of significant to be deleted. Say for instance this one, if you delete QU8, your overall Chrombar alpha would increase to 0.823. So you can consider deleting or removing the item number 8. Okay. Okay. So this is from the SPSS lah. However, this is a paper published on 2018. They say what? Thanks coefficient alpha. We'll take it from here. Means that they are, I mean, knowledge is expanding. So there are some measures that can replace coefficient alpha. So for instance, in AMOS, we do not use coefficient alpha, but we can use what so-called composite reliability, CR. One of the weakness of coefficient alpha, I think most researchers already realize this lah. If you use small sample size, the coefficient alpha will be very low. So it highly depending on the sample size lah. Okay. So that's the limitation of Chrombar alpha. So if you would like to do Chrombar alpha, that's fine. But if you have other internal consistencies tests that you can accompany them with the Chrombar alpha, then please do so lah. Okay. So Chrombar alpha, yeah. Chrombar alpha is quite easy to. Do we have some? Okay. Chrombar alpha is very easy. Chrombar alpha. So analyze, scale, reliability analysis, and then you need to include all these items, and then make sure that you are using alpha. In SPSS, alpha is the best types of internal consistency in SPSS. But in other statistical software, they may include more powerful internal consistency than Chrombar alpha lah. So choose alpha here, and then just okay, for statistics, remember to include item, scale, and scale if item deleted. So click continue, and then okay. So you will have your Chrombar alpha at 0.771, good enough, more than 0.7, and you have here Chrombar alpha if item deleted. So your Chrombar alpha is 771. So if you delete this one, question number 5, your Chrombar alpha will increase to 0.842. So just exclude that item. Run the analysis again, scale, reliability analysis, exclude number 5, okay? Exclude number 5, and then, okay, so the Chrombar alpha increased to 0.842 from 0.771. So that's how you do item analysis or internal consistency testing using SPSS. Okay, so let's move on. Okay, retest reliability. We still have time. Okay, so retest reliability is about repeatability and stability of a measurement tool. Okay, so there are 3 major retest reliability estimates. Okay, so in order to check for retest reliability, there is no single measure. There is no one single significant measure that can determine whether your instrument has high retest reliability or low retest reliability. So you need to check these 3 estimates. The first one is relative reliability. So for relative reliability, you can use intra-class correlation coefficient, ICC. Okay. Second one is you need to estimate the limits and pattern of agreement using Blond and Altman Plot. And the third one is the absolute reliability. This one is also SAM, but this SAM is actually standard error of measurement, not structural equation modeling. That is another SAM, standard error of mean. So this SEM is referring to standard error of measurement. Okay, no such thing as the significance level of test-retest reliability. Finally, it is a matter of clinical judgment as to what level the test-retest reliability can be accepted. So you as a researcher or you as a clinician have to decide. Okay. 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 Rater reliability. So rater is other persons that the participants. Okay. So rater is other person who evaluates participants' performance. Yeah, sorry, there's a typo here. Okay. So you have another person who rate your performance. You are not doing self-rated questionnaire. You are not rate using. You are not rating by yourself. It is not self-rated questionnaire or self-rated measurement tool. It is rated by other person. By clinician, by researcher, by teacher, maybe. Okay. So there are two types of rater reliability. The first one is inter-rater reliability. Measures agreement between different rater at the same time. So you have two rater 1, rater 2, and then they are measuring performance of a group of participants at the same time. So you have inter-rater reliability. Another one is intra-rater reliability. One same rater but different times. It is just like test-retest reliability lah. But for test-retest reliability, we usually refers to self-rated questionnaire. Means that participants rate themselves. Okay. What's that? Okay. So intra-rater reliability is about intra-rater reliability is about measuring agreement between different time of one rater lah. Okay. So the statistics. So how to analyze the rater reliability. Yeah. If the response is continuous, let's say scores lah, total score of QOL, for instance, QOL scale, personal well-being index, SF36, for instance, or modified Bartel index, for instance, modified Bartel index. You can always use ICC, intra-class correlation coefficient. Okay. Sorry, modified Bartel index is a good example, but quality of life it's not a good example of rater reliability because you yourself as participant need to rate for yourself because it is self-rated kan. So rater is about other person rating. Okay. So if the response is continuous, use ICC. If the response is categorical, you can use kappa statistics. Kappa statistic, yeah. So ICC more than 0.7 is good. For kappa, 0.4 to 0.6 fair. 0.6 to 0.75 good, more than 0.75 excellent. If you have two raters, you can use Cohen kappa. So Cohen kappa can be calculated using SPSS lah. Okay, but if you have more than two raters, you need to use Fliss kappa. So Fliss kappa cannot be calculated directly using SPSS. You need to install the extension first. Okay? So installing the Fliss kappa. So this is the installation lah. You can go to IBM Statistik community files and then download these files, stat Fliss kappa, and then you click at your SPSS installation, SPSS extensions, install local extension bundle, and then you can analyze. Okay. 44. Okay, that's fine. Okay, so this is how to install Fliss kappa into your SPSS. So this is your SPSS. This one. Flis Kappa. Okay, this is the data for Flis Kappa. So if you want to install the Flis Kappa extension, you always go to extension and then install local extension bundle. Then after that, the Flis Kappa will appear here. Flis Kappa. Then you just click Flis Kappa and then put all rater into rating variables and then just click OK. Okay. Okay. So your kappa, your Flis Kappa is 0.738. 0.738. Not excellent, but still acceptable because we want more than 0.75. I remember. Okay. So this is kappa lah. So for Kohon kappa, descriptive statistic, cross tab, and then just put rater 1, rater 2. I mean rater 1 here, rater 2 here, and then statistic. You can choose kappa. Continue and just click OK, and this is your kappa 0.798. This one is Kohon kappa. Okay. Okay. Let's move on. ICC. Okay. Intra-class correlation coefficient. Okay. So once in a while, some student still doing Pearson correlation, you know, to do test-retest reliability. So I would like to explain what is the limitation of doing Pearson correlation for test-retest reliability. So Pearson correlation is measuring association. Association, patterns of association to be specific. Okay. But ICC, the intra-class correlation coefficient, measures the agreement between two different scores or more. Okay. Say for instance, you have measurement A, 1, 2, 3, 4, 5, 6, 7 scores. And measurement B, 10, 20, 30, 40, 50, 60, 70. If you use correlation, you are going to get perfect correlation coefficient, which is 1.00. This is if you are using all types of correlation. Either you are doing Kendall-Tau, Pearson, or Spearman. 1.0, perfect. But if you are doing ICC, the agreement is low. Why? Because see here, 1 to 10 is actually you have discrepancy of 9 units. 10 minus 1 equals to 9, isn't it? For second one, you have a discrepancy of 18 units. So it is somehow not agree. So for test-retest reliability, we would prefer to do ICC rather than correlation lah. Okay. So okay. How to select ICC? So there are many types of ICC. There are two-way mixed effect, for instance, one-way random effects. Okay, two-way random effects. Okay, so you can always refer to this paper lah, Koo and Lee 2016. They have explained quite extensively on how to select appropriate ICC lah. Because when you are going to report your ICC results, you need to indicate what types of ICC that are you using. Okay, if it is two-way mix, then the model is two-way mix, for instance. What about the type? Is it single measure or average measure? Okay, sorry. And then the definition, whether it is absolute agreement or just consistency. This one is for the definitions. Yeah? So please have a look on Koo and Lee 2016. Yeah, to select how to select proper ICC types. Okay. Okay. So that one is for level of agreement. Now we move to Blonde and Altman plot. Blonde and Altman plot is a graphical method to compare limits of agreement between two measurements. Those two measurements can be repeated measures, measure 1, I mean test retest lah, measure week 1, measure week 2, for instance. Or these two measurements can be it is just like concurrent validity. You are comparing against a gold standard. So you have gold standard score in your x-axis. Okay, so the differences between the two measurements are plotted against the average of two measurements. This one is test retest. The differences can be plotted against a gold standard method. So rather than mean, this one is going to be the measures of or the scores of gold standard lah. Okay, this one is so this is a good blend and Altman plot lah. Very good. Most of the difference, these dots are differences between test 1 and test 2. So most of the differences is situated within 95% limit of agreement. So 1 or 2 outside is fine lah. Okay. So what to look for in blonde and Altman plot? First one is you look at this middle line. So you are going to have a middle line. So this you measure in week 1 is actually equal to measure during time 2. Yeah. So if both are similar or equal, then the differences between these two times would be 0. Sorry. Okay, so the middle line supposed to be here, around 0, but this one is -5, which means that the second measurement is higher than the first measurement. Okay, because of that it's -5. So you need to do statistical tests to confirm this systematic error. So how to do a statistical test to confirm this error? You can do either using one sample t-test. You use all your we call it differences as your data, and then you compare against a standard value. So the standard value would be 0. So comparing with 0. If it is significant, then you have a significant systematic error. The second one is based on test retest. PET t-test. PET t-test. Measurement time 1 compared against measurement time 2. If it is significant, then significant systematic error. So you need to explain why it's happening. Sometimes it is happening because of systematic error, such as maybe that person received intervention during the intervals of observations. Yeah, or maybe during the first measurement, you say for instance you measure muscle activity. So the first measurement you take your measurement during morning. Second measurement during evening. So according to the physiological theory, there are some discrepancies of muscle activity based on electromyography findings lah. So you need to take into consideration all these factors lah. Okay. Second one is you need to look for trend or proportional error. Say here is linear trend. The higher scores, the larger the difference between two measurements. So you need to report this one if you have this kind of trend. These two, the systematic error, proportional error cannot be determined using ICC. That's why you need to do a blonde Altman plot as well. Still have a few more minutes, yeah. Okay, so how to calculate this one? Just do linear regression lah. Linear regression. Okay, simple linear regression would do. Okay, and this one heteroscedasticity. See here, this is the variance lah. The variance is low here, but if you can see in this ends, the variance is very wide. Between this dot and dot, it is very wide. So it's supposed to be, I mean, in ideally, the variance between these two ends supposed to be equal. But in this case, the higher the score, the larger the variability between the two measurements. So this you need to report this as well. Means that your measurement has heteroscedasticity issue. Okay. Ideally, we want our scores to be homoscedasticity, homoscedastic, but this one is heteroscedastic. Okay. So constructing Balon and Altman plot using the, SPSS, okay, maybe later on. You can always watch in the YouTube. Yeah. So yeah, you can also do what we call it, Balon and Altman plot using Jamovi. Very good software, and it is free. Okay, so you can always do Jamovi. Maybe in future we cannot use SPSS because you can need to pay. But you can still use Jamovi lah. The weakness of Jamovi is that we cannot modify the plots. That's all. In terms of analysis, nearly complete. However, in Jamovi, there's no ICC. There is, we can produce Balon and Altman, but we cannot produce ICC, Jamovi. Okay. This one is standard error of measurement. Okay. The standard error of measurement is also a must when you are doing reliability testing procedure. So it is about error of measurement lah. So no measurement is exact. There's no 100% accurate measurement. Most measurement contains errors lah due to systematic error, the error that is consistent, or random error, the error that fluctuates. Okay, so the measured score is actually true score plus minus measurement errors. Okay, so the standard error of measurement is actually a measure of how much measured test score are spread around a true score. So this is the formula lah. This is the formula. Standard deviation times square root of 1 minus R, and R can be calculated from ICC. We can use ICC to put in the value here. Okay, so there is no cut-off point for standard error. It depends on clinical judgment lah. Say for instance, you are constructing a new types of weighing scale. Your measurement error is maybe 5 kilo, for instance. That is your measurement error. During the PKP, I've lost weight, for instance lah, 4 kilo. I think I have lost weight significantly, but actually it is not, because it is still below the measurement error. It is still error. Okay, so that's how you use standard error of measurement lah. Okay. Okay, so that's all from me. If your instrument is valid and reliable, then you are good to go. Because you know that is a saying. If you like to live in peace, you need to prepare for war. Remember, your Viva, you don't know what will happen during your Viva. So better you struggle now than you struggle then. Okay, I think that's all from me. I apologize for any shortcomings. Thank you very much.
Okay, thank you, Dr. Hanif, for the good explanation given. Now I would like to welcome Dr. Saadah to handle the question and answer sessions. Ladies and gentlemen, before we start even further, I would like to announce that we have managed to extend the time for this webinar until 1 p.m. inshallah, until all of the questions will be answered by yours truly, Dr. Hanif. I'll give now the floor to Dr. Saadah.
Thank you, Encik Awi. Okay, such a long talk, webinar, until we all need refreshment. Okay. Anyway, so I have gathered questions from the chat room just now. So let me share you the screen. So maybe Dr. Hanif can read from there and answer from the screen.
Okay.
Right. So some questions there. The first one, can we see the screen now? Is the screen okay? Dr. Hanif?
No, I can't see the screen.
You can't see the screen. Okay. Correct.
Okay.
Is that okay? All right.
Yes, starting, yes.
Yeah. The first one, what is the minimal number of questionnaires should be gathered? Can it be done in more than 2 and less than 5? So some questions here, maybe Dr. Hanif can choose and answer.
Okay, thank you very much. I will try to answer the first question. What is the minimal number of questionnaires should be gathered? Can it be done in more than 2 or less than 5? I'm not quite sure what is the meaning of minimal number of questionnaires. Is it particularly referring to the questions or the questionnaire itself? If it is the questions, then say for instance in SPSS, you need to have for one construct you need to have at least 3 to calculate the Cronbach alpha. But in MOS you need to have at least 2. Sorry, not in MOS, in other software lah, in Adanko and Smart PLS. So I hope that answer your questions lah. If you are referring to the questions. If it is about questionnaire, then you need to calculate the sample size lah. You need to calculate the sample size. Usually more than 30 lah, because according to the central limit theorem, you need to have 30 and above lah to have a good sense of normal distribution lah. Okay. That one is my question, my answer for number 1 lah. Okay.
The next one, Dr. Hanif, maybe.
Okay. The next one is, what is the difference between theoretical framework and conceptual framework? So the theoretical framework is from theory. From theory, you need to grasp that theory and modify the theory based on your research question. Say for instance, from the presentation, I've used theory of planned behavior. Theory of planned behavior is this and that. So, but in my study, I would like to see whether that theory can predict the behavior of, let's say, doing exercise, or the behavior of smoking, for instance. So I use that TPB, but all the construct I managed to use my specific construct related to my research questions lah. So that's the conceptual framework. Conceptual framework should, ideally should be adapted from theoretical framework. Otherwise, conceptual framework, there's no basis lah. Otherwise, there's no basis if you don't derive the conceptual framework from any theory. So you need to have theory lah. So the theory is your theoretical framework. What you are going to do is the conceptual framework. And then you are going to test the conceptual framework during the analysis. So in a structural equation modeling, for instance, we are testing the conceptual framework. Other names for conceptual framework is hypothesis model. Okay, we are testing the model, whether the model fits the data. Okay, I hope that's answered the second questions. The third question is, before using Q&A in your research question and answer, is it necessary to be tested for its validity and reliability on local population if it is already being done in other country? Okay, 3 types. You in using a questionnaire, you can either adopt adapt, or develop. So if you adopt, means that you are using 100% the contents of the questionnaire. If you adapt, means that you adapt some of items, some of the items, maybe because of it is not suitable to our culture. The third one is develop. You develop a new one. In terms of validity and reliability, if let's say that you are doing adaptation, adapt or develop. For adapt and develop, you need to test for the new validity and reliability. But for adopt, there are several arguments lah. Some say that because that particular, although we are using 100% same, but that particular questionnaire was validated based on Western cultures. So it is good to have our own validity and reliability. Okay, so that's the arguments lah. Okay, so it depends lah. If you have time, then if you adopt, then you can still calculate for validity and reliability, because that you need to establish validity and reliability according to our culture. Okay, but for adapt and develop, for sure, need to do validity and reliability testing. Okay. Fourth question: how many types of validity need to be tested? Depends on your capacity lah. Depends on your capacity. I mean, for undergraduate study, maybe face content and Kelompok Alpha is good enough lah. But for postgraduate, because you are going to use the result of your study for bigger purpose, for more significant purpose, then I think my suggestion would be go for construct validity, because that one is the highest. Prepare for war. Prepare for war. Otherwise, you may have to answer some questions from the examiner about validity and reliability, whether this one is good enough or not. Okay, so it depends lah. It depends on your capacity actually. Okay, okay. Then the types of validity before skill considered about validity can be okay. Okay. 5. Face validity and content validity perlu dilakukan semua atau salah satu. Untuk content validity salah satu cara, okay, atau perlu kita masuk. Okay. Okay. For content validity, okay, face validity and content validity. Do we need to do both, or we can choose at least one? We can choose one. Okay. So my experience is that according to the literature, most literature will only presented content validity lah. Content validity, because face validity practically it is not even considered as validity. But some researcher use face validity and content validity interchangeably. Mean face validity is equal to content validity. So they use the word face validity, but what they meant is content validity, because they are measuring the CVI as well as the CVR and everything. Okay. Okay. To answer the second part of the questions, okay. Do we need to do literature review, look at the previous questionnaire, and ask the opinion from the expert? Yes, yes. Otherwise, before you are going to, you need to have a sort of idea before you give the items to the content expert. So how to get the idea? The idea can be derived from literature and from expert, and then straight away you can give them to the questionnaire to content expert. So how to get the idea is from literature and from the previous questionnaire. If you have lah, if you don't have, then you have only your confidence. Then you can do as well. But the thing is, during your CVI, maybe there are questions that are irrelevant, and as well as you may have inadequate questions to represent the construct. But again, your content expert can always comment and give suggestions on which one is supposed to be included or which one is supposed to be deleted. So that one is number 5. Number 6, if we don't have time and only manage to do content validity, can we go back to do criterion validity or an other higher order validity later? That means reliability first, then only validity. I'm not so sure because where is the question? Okay, if you don't have time, okay. If you don't have time to content validity and reliability. Okay, and only manage to do content validity and reliability. So you can do content validity and reliability first. Let's say in your PhD, you don't have time to do higher types of types of validity and reliability. What you can do is you can just report your content validity and some types of reliability. But the thing is, during the Viva, examiner will ask whether this one is sufficient or not. And your question is about go back to do criterion validity and other higher order validity later. I think there should be no problem, right? Should be no problem. But the thing is, if let's say that you are doing content validity and reliability, and then you want to do construct validity. From construct validity, you need to you can exclude some of the questions. So the paper published from your content validity prior to the construct validity may use different forms of questionnaire. So the content validity using version 1, second one for construct validity using version 2. So again, it can, but you must have your reason, and you need to explain that this one is before doing construct validity. So which means that the previous one is no longer valid because you have the latest one. Okay. 7. For content validity, dichotomous or Likert dichotomous or Likert scale better. Okay. Okay. So if you have 1, 2, 3, 4, you can always group 1, 2 into 1 and 3, 4 into 2. Okay. Okay. If it is okay, let's say that you are using dichotomous. Agree, do not agree. What about I do agree, but I think that something need to be revised. So what should they score? 1 or 2. So that's why we do 1, 2, 3, 4, and then we combine later. Okay. What is layman expert? Layman expert is research, those who can become your research participants. You choose that particular person because you think that particular person can give you adequate information. So that is layman expert. How many experts needed for content validity? Depends lah. I mean, for me, to calculate the CVI, the more the better lah. If let's say that you are using 2 persons, so 1 person is agree, 1 person is not agree. So if let's say that 1 person is not agree, your CVI would be 0.5, 50%. So it is quite an error lah. So you need to have a good number lah, more than 4 maybe, 5, 6. You can always refer to my table lah. So some let's say for instance, Zaman Zadeh published a paper using 15 experts. So 15 is too much lah sometimes. Okay, maybe 4, 5, 6, 7 is good enough lah. Okay. Is EFA alone enough? EFA alone is enough. EFA alone is enough. But if you want to do CFA, if you want to do structural equation modeling, you need to confirm with CFA. You cannot use EFA anymore. You need to confirm the measurement models using CFA. So in that case, for structural equation modeling, EFA is not enough. EFA can only, okay, forgot to tell this. during EFA, you can delete as much as possible. If you want to delete, let's say you have 50 questions, you want to delete 20, can. But in CFA, you are allowed only to delete not more than 20% of the original item. Say you enter 10 questions, you cannot delete more than 2 questions. Otherwise, it is not your CFA is not valid. Okay. For EFA, 2 groups required. 1 group only. For EFA, 1 group only. IMW and KP. Okay. 1 group only. For EFA, 1 group only. Okay. If you want to do 2 EFA, that's additional lah. Okay. My question is, if I think that domains have correlation, can I use ProMax for EFA? ProMax is what? I forgot about the rotation. But if you, the thing is, you can always refer to the. I think YouTube has better video lah. It is not about thinking actually. You need to test for correlation. You need to test for that kind of correlation. You can always Google about EFA in the YouTube, and there is a method how to test for correlation, whether it is correlated or not. You can start with direct oblimin first. Start with direct oblimin, and then from direct oblimin, you can see whether your construct is correlated or not. That is a glitch on SPSS lah. So you need to do direct oblimin first according to that method. So you can refer to the EFA video in the YouTube lah. Do we need to do all 3 major test retests? Yes, yes. Because it is a matter of you have the data. It is just a matter of analysis. You need, if you want or you don't want. So if you want to have a complete picture, a complete angles of test retest reliability, you need to do all 3 test retest reliability estimates. Otherwise, you are just checking, for instance, level of measurement without knowing any possibilities of the existence of systematic error, proportional error. Okay. Yang mana tu, Mr. Cik Awi? Which one? This one. Okay. How many? Okay. How many mean sample for? How many mean sample for reliability tests using SPSS to reduce error of Romba alpha? I mean, I think it depends on your sample size calculation lah. The higher, the better. Minimum, from 3 participants you can calculate Romba alpha. But the thing is, your Romba alpha is usually low lah if you use small sample size. Small sample size. So you need to have more statistical power, and statistical power is related to sample size. So increase your power. 20 better than 10 and 30 maybe. Okay.
Hanif, have you read the 8th question?
My question is, I think okay. My question is, if I think that the domains have correlation. Yes, yes, already.
Yeah. Okay, all right. Thank you.
So again, for number 8, please refer to the EFA, how to determine whether the domains have correlation or not objectively. There are specific methods. You need to do direct oblimin first and then check whether they have correlation or not. Please refer to EFA video in the YouTube lah. I forgot lah. Okay. So number 9. Do we need to do all 3 major test retest reliability? Yes. How many minimum sample size? Yes. Assalamualaikum. Waalaikumsalam. Some studies use Pearson correlation to measure test retest. How this analysis differ? Already told you about the difference between agreement and association. So Pearson correlation measures association. If you, let's say that you have 1, 2, 3, 4, 5, and then second measurement you have 10, 20, or even 100, 200, 300, 400, and 500, your Pearson correlation would still be 1. complete R equals to 1, which is complete or perfect correlation. But if you are doing agreement, there's the agreement would be very low, because 1 in 100 you have almost 99 units of discrepancies there. So that's why we use ICC lah. I mean, previous method always use Pearson correlation, Kendall-Tau, Spearman correlation. But nowadays we use ICC lah. How to score for Likert scale items in survey rather than to analyze? Sorry, how to score for Likert scale items in survey rather to analyze Likert scale? Not quite sure what this question is all about. How to score Likert scale items in survey rather to analyze Likert scale.
I invite the person who asked the question, to ask now. Thank you. Prof. Rugaya, I think that's your question. The host, please unmute Prof. Rugaya.
Okay, wait.
Okay, Dr. Rogaya, you may speak now. I have already unmute your speaker. Dr. Rogaya, you may ask the question now. I have already unmute your speaker. Dr. Sada, I think we can continue because
she's not in the room anymore. I think. Okay. Anyway, I think that's all about it. We have 12 questions here. Do we still have time, Awi?
Yeah. Yes.
I'm inviting a question from the floor, if any. Just raise your hand. I'm not so sure we can see the raise hand in the chat. So maybe host can unmute speaker. Miss Sarah. Miss Sarah, please.
I don't know if you can hear me now.
Yes, clear.
Okay. So I have, because I already have many questions. The first one is about the phase validity. The phase validity is how can I test it? It can be a qualitative just by experts, because I read many papers about the phase validity. Some mention that it can be qualitative by experts, just they say comments, and some say it's about respondents, they can do comment, and some they do it as a quantitative, they calculate something called kappa, by calculating kappa value. So I don't know, I want to know what is the perfect method to evaluate the phase validity. This is question number one. I have another question about the construct validity, because for me, while I developed the questionnaire, okay, for me, I use it only 2 questionnaires as a reference for my study. So I don't have many questions. I only have around 30 questions. So the questionnaire is about, I didn't create with my own method, I just rephrase to be consistent with the Malaysian Director Guideline. So I didn't find that I needed to evaluate the construct validity. I didn't find that it will be suitable to my study. So because I already have subdomain and I have enough question. So does it be acceptable because I didn't run a construct validity? I just do content phase, and then I go through to the final statistical. So that was my question.
Thank you very much. So the first question is about how to determine phase validity lah. So you found that in some literatures they calculated some values for the phase validity. So,
yes.
As I said before, some researcher use the terminology of phase and content validity interchangeably. Okay, so some say phase validity, but they somehow sometimes referring to content validity, and so on and so forth. So it depends. So referring to one paper, Zamanzadeh 2000 and forgot. Okay, what Zamanzadeh did was he did three times of content validity calculation. For the first time, he did using content validity ratio, and after that, he asked the expert to rate for phase validity, and then that's it for phase one. For second phase, he did the content validity index, and after that, he asked the expert to rate on to see the phase validity again, because phase validity is also about grammatical error and something, yeah. And then the third phase, he did the we call it modified kappa, and then after that as well, again one more phase validity. So it depends lah. I think for me lah, it is better to do content validity. If you have time, then do both lah. You can always ask your content expert to do phase validity as well for you. That's fine if they are willing to lah. Otherwise, ask layman expert lah. So do content validity first, and then do phase validity. Okay. And then to answer your questions, you are developing a questionnaire using 30 questions. So that questionnaire is based on content validity only, isn't it?
Yes, I do content validity and I make phase validity, and also I did back-to-back translation. And then yes, that's all. And then I distribute the questionnaire.
I mean,
because I tried to do construct validity for the first time, but I found that the question will be around only 5 questions from 30 questions. So I tried to find where is the error. So when I tried to read, I found because the number of questions is very low. Some statistics told me you don't need to do construct validity because you already have a minimum. Because the question is already very low numbers. It's not a large number to do a construct validity. So I skip this phase and I go through directly to the distribution of the questionnaire.
Okay, I mean, as I said before, the minimum numbers for doing a CFA, the minimum number for questions, you can produce CFA if you have at least 2 questions, you can do CFA. But again, it depends on your capacity lah. If let's say that you would like to defend the construct validity of your questionnaire just based on content validity, and you need to prepare well lah, because content validity is actually to give you an idea of what construct validity is. So you sometimes, even in my my practice, I have a specific assessment called functional capacity evaluation. So they are using only content validity based on literature as well as from experts' opinion. So they cannot do constructability such as convergent and discriminant. They can't do because it is the nature of that particular instruments. The instrument is not allowed. to the researcher, is not allowing the researcher to do that particular higher types of constructability. So I think I don't know. Do you have a good sample size? Do you have large sample size?
My sampling size was around 165.
165. So if you want to do construct validity based on partially square structural equation modeling, you can still do that for that 5 questions. But it depends lah. I don't know what is your questionnaires, but I mean, if you have 5 questions and you like to check for constructability for that 5 questions using 100 plus subjects, you can still do it. Just to prepare lah, just to prepare. Otherwise, people may ask you. Say, for instance, your questionnaire is about, say, what is your age? What is your gender? That one, content validity is enough. But we are talking about latent construct. If you have latent construct, then you may need to think about constructability.
Okay.
Thank you.
Thank you.
Okay, Dr. Hanif,
Yes.
I think I would like to refer to some of the questions that are asked in the chat box. Maybe perhaps I can try to read it for you.
Okay, thanks.
Because we have been receiving quite a large of numbers from the chat box as well. Okay, from Dr. Devinder, she asks, the question is, do we need to test for reliability again for a valid and reliable questionnaire that is translated to another language?
Thank you very much. I think because the validity and reliability, the original one is in another language, you know, is in the original language, maybe in English. So if you have translated, then it is just like it is just like a new questionnaires, but it is translated based on the English version. Even if you have translated the questionnaire into Bahasa Melayu, all the validity and reliability from the English you cannot use to justify your questionnaires. So in my honest opinion, I think yes, if you have good capacity, then it is good to test the validity and reliability for the translated questionnaire again. At least content validity lah, at least content validity as well as internal consistency. If you don't want to do construct lah, if you have time, you can do construct. Okay, because we have experience. We have translated a questionnaire from English, and then when we perform exploratory factor analysis, some of the questions is not really relevant to our culture, and we miss that during content validity. The statistics show us that this question is actually has no factor loading for this to measure this particular construct. So we think about that, and we discuss with our expert panels, and then we remove that just because SPSS or Statistik shows us. Yeah. So I think because we are using different language, first. Second, we are using different population, different culture, then we need to test for reliability. That's my opinion lah. Okay. Thank you.
Okay, thank you, Dr. Hanif. We have another question coming in. So actually there are 2 questions given by the same person. First is what are the minimum content expert for content validation, and also if the respondent is less than 50 from a total population of 170, what validity tests do you suggest?
Thank you very much. So the first question is the minimum number for content validity, isn't it? Okay, so actually traditional way of doing content validity is subjective way lah, is qualitative. You ask if I'm not mistaken, Prabha told me that minimum number for content validity for the expert is 3. if I'm not mistaken lah. That one is referring to qualitative way lah. Qualitative. If you are referring to content validity, so if you have like 3 participants, the number you will get for the CVI are either 33.3, 66.6, and 100%. Okay. So even you have 2 expert panels scoring good, you cannot still achieve 0.7 or 0.8. So that's the issue lah. So the bigger the better. For me, at least 4 lah. At least 4. At least you have 25, 50, 75, and 100% of these categories lah. At least that lah. So the second question is about if you have okay, this person have less than 15 participants, what types of appropriate validity testing? I mean, less than 50 participant, less than 15, you can do content validity, you can do face validity, you can also do item analysis from alpha, and that's it. Yeah, that's it. Okay.
Okay, Dr. Hanif, I think we take just another one more question before
Sorry, Mr. Awi. One more thing is you can do retest reliability. 15, repeat the test maybe after 1 week or after 3 days. It depends on your interval based on your area. And then you calculate for retest reliability. Because I've done in my PhD, 9 participants do the Blonde and Notman, ICC as well as standard error of measurement. So you can do retest reliability as well. Thank you.
Okay, Dr. Hanif, I think we take just another one more question before we sum it all up. Given by Siti Munirah, she would like to ask if the ICC score is less than 0.8, what should we do to improve the score?
I think ICC score is less than 0.8. If it is 0.7, I think you can still justify lah. 0.75, there are some authors suggesting more than 0.75. Some say more than 0.7. But in order to improve the ICC, okay, how to improve ICC? That is why, in my opinion, you need to establish your validity first lah. If your item is valid, then it is most likely that you are going to get good test reliability. But if you already have your ICC less than maybe less than 0.6 or less than 0.5, low, so it is fine. It is fine. Because in order to say whether the measurement is have good retest reliability, you are not referring to ICC only. You are not referring to ICC only. You also referring to Blonde and Notman as well as standard error of measurement. So if ICC is low, then try to justify your retest reliability based on Blonde and Notman and the standard error of measurement. Okay. Thank you very much.
Thank you, Dr. Hanif, for the neat explanation. I'll give the floor now to Dr. Saadah.
Okay, thank you, Dr. Hanif. Very informative, So we have listened to Dr. Hanif lecture, very informative, and answered all the questions. But I see some questions still in the Google chat, the group chat. And unfortunately, we cannot entertain. Maybe to those who have sent the question in the chat may communicate with Dr. Hanif through email. So sorry for that. So okay, so I think we have to stop now. So we have learned a lot from Dr. Hanif today, and I can see the next Prof. Bahar, knowledgeable and philosophical, a warrior. Okay, all right. So thank you very much. Back to you, Awi.
Thank you very much.
All right, thank you, Dr. Saadah. I would like to first and foremost say congratulations and thank you so much to Dr. Hanif for finishing the webinar Statistik, which is the first time it has ever been done through online. I would like to also congratulate to all of the participants for staying throughout this entire time with all of us. For your information, the highest amount of participants recorded for today was 110. And I would like to say congratulations to all. I have just few announcements to make. Number one is like what I said in the chat box, for the staff members that have not yet filled in the Google form for registration for eSpell, you may do so through the chat. And for the students that have come in that have not yet registered initially, I mean, they came in quite late, latecomers, you may also register via the Google link, which I have already provided in the chat box. And ladies and gentlemen, last but not least, inshallah, we will try to distribute these recording sessions to all of the participants for your future reference. That's all from me. I would like to say again, thank you so much to Dr. Hanif, to Dr. Saadah, and to all of the academicians, and also the staff members, and also the postgraduate students participated in today's webinar. Until next time, I hope all of you have a good Ramadan, and thank you so much. That's all.
Thank you very much.